Get it back tomorrow. All right, so we're going to look at functions defined by integrals. So we're going to still be spending lots of time with integrals here. All right. So we can have a function. So this right here, actually, I think that's the same thing. This is, excuse me. This is what a function defined by an integral is. Okay, so g of x equals the integral from 0 to x of f of t dt. And remember, these variables have to be different. So here's the graph of f. Okay, does f equal g? What does f equal as far as g is concerned? Think about that. So this is the graph of f. Is that the graph of g? Right. So it's the derivative of g, because this is the derivative of something, right? And so once I integrate it, it kind of undoes that derivative. So the graph of f, that's equal to g prime. So f and g prime are the same thing. It's important to label it as such, okay? So basically what we have here is that g is equal to capital F. No, you don't. Did I give you the wrong thing? Oh, I gave you day 2. Dang it. Now that we all have the correct papers. If I integrate little f, I get big F. So that means g is equal to big F. So g is equal to big F, so g prime is equal to little f. Does that make sense? And I'm going to denote it over there so that we make sure that we know what's going on with our graph. Okay? So here's how these work. I'm going to find g of 0. Okay, so just like anything else, we're going to substitute this in. So g of 0 is equal to the integral from 0 to 0 of f of t dt. And what is that? 0. Why? There's no change. When the limits of integration are the same, the integration is 0. There's nothing to integrate, right? I can go anywhere. So I want g next of negative 1. That's equal to the integral. So I'm getting this from this function defined by an integral of 0 to negative 1 f of t dt. Okay, so when I'm looking for the integral of something and I have the graph, what concept am I using from the graph? What do I have to find of my graph? Area, okay? So since we know we have to do area, let's just go ahead and find area of little pieces. It'll just kind of make things easier. So if I break this here, I've got this triangle. The base is 1, the height is 2. So what's the area? 1. Okay, it tells me that this is a semicircle. Radius is 2. Area of the circle would be 4 pi. This is a fourth of it, so that's pi. You can break this little triangle off. I got 1 times 2 divided by 2 is 1. And then what is this shape? A trapezoid. So I'm going to add the bases together. That's 1 plus 2. That's 3. Times the height, which is 2. And then I divide by 2, so this area is just 3. That way all my pieces are there, so we think through this. We don't have to go calculate area every time. All right, so I'm integrating from 0 to negative 1. The area of that triangle is 1. Is my answer 1? What is it? Negative 1. Why? Good, because I had to flip the x. So we can think about it 2 ways. We can think about the fact that when we flip this around, it makes it negative, because that's what's happening with our integral. You can also think of it graphically. If you're going to go from right to left, if you're going backwards, then it changes the sign. Okay, but either way, it's negative 1. Well, good with that? Both ways, you kind of need to understand both ways. All right, so then we want g of 2. G of 2 is equal to the integral from 0 to 2, f of t dt. All right, so from 0 to 2, that's just what? Pi. So then we also want g of 5. It's equal to the integral from 0 to 5, f of t dt. It's what? 4 pi? 4 plus pi? Tell me, besides the values, what's the difference, besides the values, what's the difference between these two areas? This is negative. The area itself is positive, but because it's below the x-axis, the value is negative. So if I'm going to go from 0 to 1, 2, 3, 4, 5, this is going to be pi minus 4. Any questions at this point? Good? All right. So now we're supposed to find all the values of x on the open interval from -1 to 5 in which g has a relative maximum. Okay? When g has a relative maximum, how do we figure that out from the derivative? Okay, we can look at the fun box. All right. So your fun box here, f prime, f double prime. Right? So when f is going to have a relative maximum when it changes from increasing to decreasing, right? So if f is changing from increasing to decreasing, that means f prime is changing from positive to negative, right? So I need to, so where does this change from positive to negative? At 2. Okay, so it says for all values of x, it's not asking me for what it is. So I can say it's at x equals 2. So I can say g has a relative maximum at x equals 2 because f, which equals g prime, okay? So since I'm talking about g, I have to talk about g prime. That's something we labeled. That's because we know it's f. So when we do something like this, we have to say that. Does that make sense? All right, so g has a relative max at x equals 2 because f, which equals g prime, changes from positive to negative. We okay with that? What questions we got? All right, so this was relative maximum or minimum, right? Now it asks for absolute absolute minimum. How do you remember what we did for absolute minimum? Well, we did sometimes. We use the second derivative test, but can we find the second derivative here? No. Okay, so I'm not capable of finding the second derivative, even though the second derivative test is a thing that we did. Do you remember something called the candidates test? Okay, so absolute minimum can occur, right? So absolute minimums at endpoints or critical points. Make sense? All right, so my candidates test, and here we're using x and g of x. So when you look at that graph, so you're going to have to look up at your graph so I don't have to keep scrolling back and forth. The endpoints are when x equals -1, when x equals 5 is the other endpoint, right? And then my critical points happen at 2. That makes sense? All right, so then for g of x, do I know what g of -1 is? No. It's -1. We found it, right? It's -1. So g of -1 is -1. We found it in part A. Do we know what g of 2 is? It's pi. Do we know what g of 5 is? It's pi minus 4. So what are we looking for? Absolute minimum. So this is positive. Pi minus 4 would be negative, but would it be less than -1? No, because this is 3.1415, right? So this is negative, less than 1, whatever it is. All right, which means that we can say let's see, so find the absolute minimum value of G. So the absolute minimum value of -1 occurs at x equals -1. And you understand that those two -1s are different, right? When it says the value, this is the y value. That's what it is. Where it is the x value. Everybody okay with that? Let's look back at something else. Let's say that we didn't have these. Okay, let's say that we didn't already find that. We would have had to find it here, right? But here's something else we know. One of our critical points is when x equals 2. But look at what we'd already found. We'd already found that it's a relative max. If it's a relative max, can it be an absolute min? No. And we figured that out without worrying about what it actually is. You with me on that? So if you were here, instead of putting a value here, you could have just said, I mean, which is fine, we already had it, it was easy. But you could have just said that it is the relative max. Like you wouldn't have to find it. Does that make sense to you? The other thing, which I purposely left off this time just because I didn't want to throw anything off, but I could have said absolute, oh, I said abs, just the abs, absolute minimum. Can occur at endpoints, or actually the absolute's anything, can occur at endpoints or critical points. But specifically the minimum, it occurs at the endpoints or when G prime changes from negative to positive, and we can see here we don't change from negative to positive at all. And if you say that, if you actually say that, then you wouldn't have to even write that. But I do, because there's some little nitpicky things about like what are they going to accept, what do you have to put. I would suggest just go ahead and put all the critical points so that you don't leave anything off, because if you do omit something over here, you have to explain why. And trust me, it's much easier just to put it all in there. So just put all the critical points in there, but if you already know it's a relative max, you wouldn't have to calculate it if that was something extra you had to do. Okay, we good with that? All right. So now we're talking about point of inflection. Whew, knocking off the cobwebs, right? Find the x-coordinate of each point of inflection on the graph. So do you remember, how do we figure out point of inflection? So our critical points is when we change from positive to negative or negative to positive. Point of inflection is when the derivative graph changes from increasing to decreasing, right? And so specifically when we're looking at max and min, whether we go from positive to negative or negative to positive, it matters, right? For a point of inflection, it's just a difference between increasing to decreasing, or it doesn't matter which way we go, okay? Does that make sense to you? All right, so where is the first x value? Well, actually, let's just start a sentence first. The x coordinate for each point of inflection. So I can say G has a point of inflection at x equals, okay, so where's the first time we change from either increasing to decreasing? Okay, at 0, because we go from increasing to decreasing there. Then as we go along the graph, it's decreasing until 2, but it still keeps decreasing, right? And then at 3, it starts increasing, right? So inflection at x equals 0 and x equals 3, because G prime equals F, right? Or F equals G prime, either way. Changes. Now the wording you put here can make a difference. I don't want to say changes from, I could say it changes from increasing to decreasing or decreasing to increasing. Or I could say changes between increasing and decreasing, because that doesn't denote which way it's going, right? Or you could just say increasing to decreasing or decreasing to increasing, whatever. Oh, between. What questions do you have? Anything? All right. Let's look at this next one. Okay. So we got this graph here. We're going to do some integrals. We'll worry about the area when we get there. This was on the 2004 test. Yes. And there's been similar things along the way. We just pull up there. I haven't pulled anything. Everybody else has been doing everything. But they pull off quite, like there's other similar ones, but they all might be a little bit different as we go along. So even though, yes, it's probably older than you are, it's still a valid question. I mean, it doesn't change that much. Okay, so the graph of function f shown above consists of a semicircle and 3 line segments, okay? So then there's no question that that's a semicircle. Let g be the function given by, okay, so I've got g is equal to this, which means g equals capital F, which means little f is g prime, right? So what if I find g of 0? G of 0 is equal to the integral from -3 to 0 of f of t dt. So from -3 to 0, I have this area. Right? So I'm going to add, it's a trapezoid, very good. So I'll add my bases. That's 1 plus 2, that's 3, times the height, 1, 2, 3. So 3 times 3 is 9. Take half of that, I get 9/2. Everybody okay with that? Then I want g prime of 0. It's what? Y. Exactly. F is g prime, so g prime of 0 is 1. I just pulled that right off the graph. Everybody good with that? Okay, so we're going to rewrite this up here. So we found that g of 0 is 9/2, right? And we found that g prime of 0 is equal to 1. What would g double prime of 0 be? I'll think about that while I go get my tea. How do you think we're going to find that? Find the slope, right? So if you're taking the derivative of the graph that you have, so that this is the derivative of this graph, it's the slope, because the derivative gives you the slope, right? So at 0, so g double prime of 0, what's my slope? Negative, wait, oh, never mind, it shouldn't be g of 0. It should be, because we can't find a slope right there, right? That's not what I wanted. It should be g of 3. G double prime of 3, just randomly. Sorry, I had all this written out and I was all ready, and then this is something she showed me just a minute ago that is good to talk about, to remind you that we're finding slope. G of 3, 1, 2, 3, then this slope here is just -1, okay? All right, so what did we do to find g of 0? How did we find that? The graph. What do we do with the graph? We found the area. So g of 0, we found the area. What did we do to figure out g prime of 0? We went back to the graph. It was just a point from the graph, right? Oops. Hang on. And then what do we do for this? Slope. So these are how these three things are related to each other when you have a function defined by an integral, okay? Function defined by an integral, the function itself, you find area, the derivative is a point, and the double prime is a slope. Make sense? We good? Okay. So next it says, find all values of x in the open interval at which g attains a relative maximum. So if g attains a relative maximum, that means this is when f, which equals g prime, or g prime, because we're talking about g, changes from what? From positive to negative. Okay, we good with that? So that's something we're thinking. So then we can go look at this graph. Where do we change from positive to negative? It only happens once, right? It's at x equals 3. So then I can say g attains I would just use the words they use. G attains that's a strange way to say it, but a relative max at x equals 3 because G prime, which equals F, changes from positive to negative. So relative, that's a positive to negative thing. Absolute minimum. We have a couple of options here, but what's one thing we can do with the kind of information we have? Just like we just did. Candidates test, right? So, and this can occur anytime you have at any endpoint and at any critical point. So we're going to have an x and we're going to have a g, right? So our first endpoint is what? Yeah, look at your graph, find the mistake. Where's the mistake in the graph? It says 5. It should be negative 5. So your first endpoint is at negative 5. The other endpoint is at 4, right? And then we have a critical point at 1, 2, 3, 4, negative 4. Is that correct? Some counting on there. And 3. Okay. Let's see. Do we know these things? G of, we don't know that one. So G of negative 5. So remember, this is where we get G from. G of negative 5 is the integral from negative 3 to negative 5. So I'm going from negative 3 to negative 5. Probably should have found these areas and we didn't, so let's do that real quick. See, this is 2 and 1. So that's 1, and that's 1, right? Well, the area itself is 1. Does that make sense? Okay. And I'm going to go from negative 3 to negative 5. What happens to these two areas? They just cancel out. So that means when I go from negative 3 to negative 5, it's just 0. So this one is 0. Then G of negative 4. So negative 4 is going right here. So I'm going from negative 3 to negative 4. What's that value going to be? Close. Negative 1. I'm going to the left. So the area is 1, and it's a positive 1 for that area, but I'm going to the left, from right to left, so that I changed the sign on that, and that one is negative 1. Okay. Then I want G of 3. 1, 2, 3, right? And so I'm going from negative 3 to 3. So this right here, it's 9/2 plus this mess right here. Yes? So let's talk about that, and then we'll tell you what we can really just write here. But how do I find the area from 0 to 2? How do I find that? Because the area under the curve from here to here is this part, right? You have that? That's on one of the assignment you had from yesterday as well. Good. It's a shaded area type thing. I know y'all did this stuff in geometry. You have an area of a rectangle, and then you subtract out the semicircle, right? So the area of the rectangle is what? 2 times 1. So that's 2 minus, and then this is 1, and so that would be pi halves. That makes sense? Okay. Now, so we can add that to 9/2 if we want to, but look what we just did. We have a relative maximum at x equals 3. We're looking for an absolute minimum. So right here I can just write this is the relative max. Because the justify your answer part, guys, that is this. So you can't just leave it blank because you know what it is. You with me on that? That's all. So we don't want to just leave it blank. When I want 4, so let's look at this. I'm going to go from negative 3 to 4. Then I'm going to have to add a little bit more there, right? But let's think about what's happening here. If I'm going from -3 to 4, tell me about this area, all of the area that I have. It's all positive, right? I'm looking for an absolute minimum. Do I have something that's not positive? Yes. So then do I really care what the actual value is here? It's not necessary. So it's fine just to put that it's positive. Because that's an understanding of the area. Don't get lost in the actual numbers of it if you don't need to. Okay? And then we can say, so absolute minimum value. So the absolute minimum value, what's the absolute minimum value? -1, good. Absolute minimum value of -1 occurs where? At x equals -4. So the minimum value is -1. It occurs at x equals -4. Jeremiah, come on now. What questions we got? All right. Find all values of x in the open interval for which the graph has a point of inflection. So point of inflection from a graph, because the second derivative test isn't going to help me here with this kind of stuff, right? Point of inflection, I am looking for g prime to do what? Increasing to decreasing, okay? And so when you look at this, so let's just start our little sentence here. We can say g has a point of inflection at, all right, so where's the first time we change from increasing to decreasing? -3. At x equals -3. When's the next time? At x equals 0, are we changing from increasing to decreasing? Because x equals... Okay, so look, I'm going along here. I'm decreasing, right? When I get here, I change, but I'm still decreasing, right? I start here, I start increasing, and then I start decreasing. So it's here and here. So x equals -3. What was that? I already scrolled 1 and 2. Yeah. Because g prime, which equals f, changes between increasing and decreasing. Okay. What questions do you have? Are we good? Okay, so you have like 2 questions that are attached to this, I think. Oh no, you have, I didn't stable this correctly. Is that it? Oh yeah, okay, good. So I want you to get those 2 questions done before tomorrow, all right? Because we're going to start with the same stuff. I'm going to give you all some time to work, and then we're going to score the question like it'd be scored for AP.